Okay, so topic of my talk is highly scalable and dynamic grids. And I have 20 minutes to tell you all about that. So I guess I should be moving on pretty quickly. So here is a little picture that I have recently come up with. And it is certainly simplified. So what I have here on the horizontal is jobs per second, which means how many jobs per second finish in a grid. Whereas here on the vertical, it's a number of cores per job. So for any given job, how much cores does a job use? So if you look at that picture, then I have identified a few, let's say, typical scenarios, such as a cluster supercomputer like TAC, where you have, well, up to a couple of 10,000 cores per job, actually, and job run times which go in the, well, eventually even months or so. But so in order to fit it on the slide, I have just made it here 10 to the minus 2, which is, well, a couple of 100 seconds. Then, for instance, for a typical MCIe site, let's say crash simulation or something like that, usually you see processor sizes from between, let's say, 4 to 32, something in that vicinity. And job finishing rates are in the order of, well, let's say, a couple of jobs per second. Then typical EDA job, typical EDA scenario, you have a couple of 100 jobs finishing per second eventually. But jobs are usually restricted to 1, 2, 3, 4 cores. And then finally, a typical XTP, which is extreme transactional processing. That's mostly in the commercial financial sector. You actually could have many 10,000s of jobs finishing each second, and each of them being just a few milliseconds long. But they usually, so they usually have just 1 or 2 cores busy. So don't take this curve too serious. There's certainly no good way to interpolate between these. I've just painted it in for my later argument. And then that's why I'm saying also it's simplified. What it doesn't say, for instance, how many nodes such a cluster uses. I mean, there's difference, obviously, whether you run something like this on a 10-node cluster or on a 100-node cluster. So if we look at this, then what we can say that to the left of this little graph, that's sort of the state of the art. Well, as you move up, it's also a little bit challenging, but it's kind of the state of the art. Whereas on the right-hand side, that's kind of the challenge area when you talk about grid scalability. Then another version here. If we dissect this into what's batch processing is used. Wait a second, I see something. That's actually an old version of my slide. Wait a second. Sorry about that. It's actually wrong. Okay. So first of all, now there's also the 10 to the 0, which some of you might have caught. And then secondly, is it coming? And then secondly here, there's actually sort of the correct picture. So if you dissect this into batch processing and what could be called transactional processing, then you basically see that there is kind of a line here to the horizontal, to the vertical, and what makes a difference is basically the response time here. So the number of jobs per second that finishes. Batch processing goes only so far, like here, a couple of 100 jobs per second to finish, whereas transactional processing can actually go farther. But then if you look into managing parallel jobs, then batch processing is the tool that is better suited. And we'll kind of see why that is in a couple of the next slides. So a few things, first of all, regarding those use cases. In terms of requirements, I'm not going to read them all. They will be in the online proceedings, but just to give a flavor. So on supercomputing, for instance, what's important is, I mean, it's usually budget managed. So in other words, you need to manage things like shares, quotas, and so on. They have huge parallel jobs, so you need to start them up fast. There's no point in starting up a 32,000 core job and waiting 50 minutes until it comes up. So data grid, for instance, is very important. Then secondarily, stuff like multi-clustering. What's not as important actually is, for instance, throughput, which is very much in contrast, let's say, to typical EDA. Throughput is the most important thing in typical EDA sites. Then also managing the right priorities, different projects managing against each other. And for instance, stuff like license management integration, which is not as hot in supercomputing cluster. Let's see whether a few other things to point out. If you look at system management, for instance, I don't have system management as a hot requirement in typical EDA. Why? Because they already have system management implemented, basically. EDA is using grid systems since more than 10 years. So if they don't have something set up already, then there's something wrong. That's not quite true in some of the other cases. Electronic design and automation, chip design, sorry. So MCIE is mechanical computer-aided engineering. That's okay, so jumping on to one of the biggest systems and definitely one of the biggest clusters built today. So SunGrid Engine is going to be used by tech, and some of the requirements that we saw there are, for instance, advanced reservation. Then, as I said already, fair share and accounting. They have long-running jobs. So that means you actually have to do the accounting basically during the job run. So you have to get online accounting information, feed this into the fair share processing, and adjust priorities according to that. Then in terms of scalability, if you just look at the fact that it has 64K cores, about 4K hosts, then with our default load report interval of 15 seconds per host, you will get something like 260 plus load reports per second. That alone is something that needs to be managed. And then there are actually up to tens of thousands of MPI tasks for a particular job. So what you need here is fast startup, fast deletion. Of course, it needs to be robust. And you have to be able to handle the continuous reporting of tens of thousands of accounting records. So that's alone is, again, a huge scalability requirement. So some of the things that we have been doing and are still doing for tech. So one is advanced reservation. That's actually already in an early access version since June 07. Then in terms of scalability, and everything that we do for tech also benefits other market areas such as MCIE or EDA. So our QMaster process, which is the central control unit of SunGrid Engine, is multi-threaded. That's actually the case since 1.5 years, but there is lots of things always to optimize around multi-threading. One of the things that we have optimized, for instance, is pulling back our scheduler into the QMaster as a thread. The scheduler used to be a separate process back from the days when multi-threading wasn't really reliable and stable. So we have pulled that back. The communication system, for instance, is completely multi-threaded. Then we also internalized remote execution for the fast startup of jobs. Those of you who are familiar with Grid Engine know that we previously basically offhanded into remote shell or a secure shell to start up parallel jobs, the parallel tasks on the remote systems. Now that's internalized into the grid engine system, making it more efficient, making it much quicker for the startup and also for the deletion. Then we use caching, packing, hashing, and so on extensively. If you imagine systems of that size, then you have huge lists of, for instance, nodes, huge lists of jobs, huge lists of users, and you have to go through them constantly, searching for matches and so on. And you have to do a lot of optimization in order to not have a slowdown there. And oops. We have externalized the processing of accounting data. So accounting data, in our case, as soon as it accumulates, it's immediately written off to an external process and then from there handled completely separately. So if you do any accounting in our system, you do not impact the overall performance of the system itself. So, so this is the supercomputing side, and as I said, this is also helping MCAE and EDA. If you look at throughput computing beyond batch, where basically batch processing doesn't work anymore, then you need something different. So why do you need something different there? If you look at a traditional distributed resource manager, so a batch system such as SunGrid Engine, they are kind of push system. They have this omnipotent scheduler, so like our QMaster in combination with the scheduler process, which makes decisions and then pushes jobs out. It needs to do so because it actually manages policies such as fair share and so on. So it needs central control. It really needs to know what's going on. Otherwise, that's simply not possible. So that actually allows for highly sophisticated policies and so on, but it isn't as responsive as it is needed in these extreme transaction processing, or as it also is called, extreme online transaction processing or extreme transaction processing, or like we call it microtask processing cases. So this microtask processing is a different approach. It is pull. So what it actually builds on is a ultra-fast data store, and basically tasks are just pulled in out from this ultra-fast data store, processed, and then inserted back into the data store. But what it means is there is no scheduler. There might be something that works on this data store, classifying the tasks and accumulating the answers, but there's not really a policy engine that does highly sophisticated stuff. So it's very responsive, but it cannot do that level of policy. So that's why we believe there actually need to be two distinct technologies, classical batch and transaction processing. Now, what do customers do who actually want both, actually have both cases? You find that, for instance, in the financial area, they do have batch processing, for instance, for risk portfolio analysis, but they also do have transactional processing needs for their transaction handling, for instance, order processing and stuff like that. One thing that we're working on is called service domain management. And if you look at this picture and you imagine, okay, this is the type of equipment which they have, then there could be a SunGrid Engine grid very much to the left. Then either another SunGrid Engine grid or another service, which could be a microtask processor. And then, for instance, there could be also a spare pool. And based on service levels, the service domain manager could reallocate resources in between those different, we call them service containers. So for instance, over the day, you could be switching more to a transactional processing, and over the night more to the back-end analysis. The way how this flows into the SunGrid Engine portfolio is shown here. So if you are familiar with SunGrid Engine 6.1, then it's basically just the SunGrid Engine workload manager and the accounting and reporting console. For 6.2, we actually have an extension here. There is a multi-clustering functionality coming, which is implemented with this service domain manager module. within calendar year 08, we're looking for a further extension. We have SunGrid Engine, and then via this Service Domain Manager integration, the possibility to manage 2 types of containers, SunGrid Engine or a microtask processor. And then if we look further into the future, we could also integrate other services, such as application servers and so on. So in terms of roadmap, what's coming? So we currently have we're at some update level of 6.1. Actually, 6.1 U3 is coming out pretty soon. But in terms of the new stuff, we will have an early access of the 6.2 with the multi-clustering in February, March. The microtask processor is not yet confirmed, so I've left it here as to be done. And the 6.2 is then coming out as release in May and June. And afterwards, we will have half-yearly feature updates. So just wrapping up the upcoming SunGrid Engine 6.2. So once again, early access in February, March. The beta program is announced here at Supercomputing. I mentioned the release already. Some of the major improvements are obviously the scalability, then advanced reservation, the multi-clustering, and some Sun housekeeping integration with Solaris Management Framework and Sun service tags, plus some new pricing options which I cannot yet describe. And finally, here at Supercomputing, we have a demo of an integrated Solaris HPC stack, which is really complete, scalable, reliable, and fully supported by Sun. It consists of Solaris with D-trays, CFS zones, and so on. Then SunGrid Engine, Solaris cluster as a high availability failover solution, and finally the Sun cluster tools for the communication. We have a presentation by Dan Templeton, specifically on 6.2 in the Sun Booth Theater. I believe it's 8 p.m. tomorrow, but on Monday, sorry, but I'm not entirely sure, so please check the booth schedule. We have a developer DVD giveaway, which consists of Sun Studio, Sun Cluster Tools, and SunGrid Engine. And then we have a couple of partners presenting around SunGrid Engine. So there is Univa, United Devices with Cluster Express, which includes SunGrid Engine, and their launch of grid.org. And finally, Nietzsche is presenting their engine frame portal integration with SunGrid Engine. So with that, I'm basically done. So come see us. And if there are any questions, and if there is time for questions, then I'm happy to answer.